Hello students, this video lesson is an introduction to fractions. Fractions are numbers that represent a part of an integer or part of a whole number. Fractions are written in the form a over b. A represents the numerator and b represents the denominator. And b, the denominator, can never be 0. That's because division by 0 is undefined. Some examples of fractions are 1/2, 5 over 3, -8/17, 3/4, -10/2. A fraction bar is simply another way to represent division. 20/24 is the same thing as 20 divided by 4, which equals 5. The numerator, which is the top number of a fraction, a good way to remember that is in the word numerator, there's a u, and in the word up, there's also a u. So think of numerator as the number up on top. Denominator is the number down on the bottom of a fraction. A nice way to remember that is to connect the D in the word denominator with the D in the word down. Fractions fit into a category called rational numbers, which is within the set of real numbers. We've talked about whole numbers, which are 0, 1, 2, 3, 4, and so forth. And we talked about integers, which are all of the whole numbers and their negative counterparts. Well, rational numbers are any number that can be represented as a fraction or in the a or b form. Again, where a and b are both integers and b can never be 0. This includes all of the whole numbers and integers because any whole number or integer can be made into a fraction by simply putting it over 1. So I could say -5 over 1, which is a fraction, which is also simply -5 divided by 1, which equals -5. 0 over 1 is 0, and 3 over 1 is 3. These are integers that, when put over 1, simply really are themselves, but they can be represented as a fraction. What's interesting about division, division can be checked by multiplication. So I could take the quotient, the answer to the division problem, and multiply it by the denominator. 1 times -5 is going to give me what my numerator is, -5. 0 times 1 is 0. So the quotient, the answer to division problem, times the denominator should equal the numerator. 3 divided by 1 is 3, and 3 times 1 equals 3. So division can always be checked by multiplication. Now I'd like for you to stop the video and divide the following fractions, and then check your answer by multiplying the quotient, the answer, back with the denominator to see if you get the numerator. So how'd you do? If I take -15 divided by 3, I'm going to get a -5. Because remember, a negative divided by a positive gives you a negative number. And then I can check that back because -5 times +3 gives me a -15. 54 divided by 9 equals 6. And I can check that back by multiplication by taking 6 times 9 to get 54. Then my last fraction was -42 divided by -7. A negative divided by a negative is going to give me a positive number, +6. And I can check that by taking +6 times -7 to get what the numerator was, -42. Now, Earlier I said that in the A over B form, the B can never be 0 because division by 0 is undefined. So we exclude the fraction 1 over 0, or any number over 0 is excluded from our number system because it does not fit the rules like all the other numbers in the system. For example, it cannot be checked back with multiplication like other division problems, like the ones we just did. So if we say 1 divided by 0 equals 1, and we try to check that back by taking 1 times 0, we don't get the numerator. 1 times 0 is 0. It doesn't work. So let's say we say 1 divided by 0 equals 0. Again, if we try to check that back by taking the 0 times the 0, we still don't get the numerator. We get 0. Because 0 times anything is 0. So because it simply doesn't work, it doesn't follow the rules, we exclude it. We just simply say it's undefined. Because division will always be checked back by multiplication in all the other instances, but not with 0. So it just gets kicked out. A nice little phrase is, when 0 is under the line, it is undefined. That's just a little handy saying to help you remember that when the 0 is under the line, it's simply undefined. So fractions represent a part of a whole. The denominator, the number down at the bottom, tells us the type or size of the part, and the top number, the numerator, tells us how many of that size or type we have. So if I had 3/4 of a pizza, and the pizza was cut into 4 pieces, with each piece representing 1/4 of the whole pizza, this fraction tells me I had 3 1/4 slices of pizza, leaving 1/4 slice for someone else. But if I cut the pizza into smaller pieces, say into 8 pieces, I would have had 6 1/8 slices of pizza, leaving 2 1/8 pieces for someone else. See, the smaller the number or actually the larger the denominator, the smaller the piece. So whether I had 3/4 or 3 1/4 slices or 6 1/8 slices, I still had 3/4 of the pizza. The second pizza was just cut into smaller pieces. These are equivalent fractions. Now, an improper fraction is a fraction when the top number, the numerator, is larger than the bottom number. The fraction is called improper. It's top-heavy. 5/2 is an example of an improper fraction. Mixed numbers are numbers that contain a whole number part and a fractional part. Improper fractions can be changed into mixed numbers, and mixed numbers can be changed into improper fractions. To change an improper fraction to a mixed number, long division must be done. So if I have 5/2, 5 divided by 2, or 5/2, and I wanted to change that to a mixed number, I simply put it into a division problem, a long division problem. 2 goes into 5 2 times, so that what goes on top. I take the 2 that's on top times the 2 that's out in front, and I get 4. I place that underneath, I subtract, and I get 1. Since there's no other numbers that comes down, that is the remainder. That remainder becomes the numerator of my fraction part. And then whatever number was out in front becomes the denominator. So 5/2 becomes 2 1/5. We have our improper on the left and our mixed number on the right. Another example of long division is 1,405 divided by 7. I put that into a long division problem. 7 goes into 14 2 times, so the 2 goes on top. The 2 on the top gets multiplied to the 7, which is 14, which gets placed underneath. When I subtract, everything goes away, 0. So I bring down the next number, which is also 0. 7 can't go into 0, so I place a 0 up atop. 0 times 7 is 0, which goes underneath. I subtract, which is 0, and I bring down the next number, which is 5. Well, 7 can't go into 5, so I put another 0. So 0 times 7 again is 0, 5 minus 0. Now, since there's no other numbers to bring down, that 5 is the remainder. So that 5 becomes the numerator, and the denominator is going to be 7, which was the denominator of the original fraction. So again, I have my improper number on the left and my mixed number on the right. So this is a demonstration of how fractions, an improper fraction, can be rewritten to be a mixed number. Now I can change a mixed number back into an improper simply by multiplying the whole number with the denominator, add the numerator, and put the results over the stated denominator. So here's an example. If I have 6 and 5/7, and I want to change that to a mixed number, I take the number out in front, the whole number, which is 6, times the denominator, which is 7, and I get 42. And I add that 42 to the numerator, which is 5, which gives me 47. And I put that 47 over the denominator that I was given on the fraction part. So 6 and 5/7 becomes an improper fraction of 47/7. Improper fractions can be represented as pictures. If I have two whole, it's like two whole pizzas and 1/4 of a piece. That's 2 and 1/4. Or I can make that into a mixed number, or an improper fraction, I'm sorry, by taking the 2 times the 4, which is 8, plus the 1, which is 9, over the existing denominator, which is 4. So I basically have 9 slices of 1/4 pieces. Equivalent fractions. Equivalent fractions represent the same amount, just each part is a different size, like in the previous example with the pizzas. The larger the denominator, the smaller the piece. To create an equivalent fraction, just multiply or divide the numerator and denominator by the same number. Equivalent fractions, fractions that represent the unshaded area for each, they are equal. I have 1/4, 2/8, and 3/12. I have the same size rectangle. It's just the first rectangle is broken down into 4 pieces. The second rectangle is broken down into 8 pieces. And the last rectangle is broken down into 12 pieces. But the shaded area represents the same amount of that rectangle. So that 1/4, if I took it, the numerator and the denominator both multiplied it by 2, I would get 2/8, which is demonstrated in the middle rectangle. If I took that 1/4 and I multiplied the numerator and denominator by 3, I'd get 3/12. And again, I could go backwards. If I had the 3/12 to begin with, and I divided it, the numerator of it and the denominator of it, by 3, that would take me back to 1/4. Just as the 2/8, if I started with that, but divided the numerator and denominator by 2, I would end up with 1/4. So whether I'm breaking it down into smaller pieces or putting them back into a larger piece, I have equivalent fractions. The number parts that are selected represent the numerator. The total number of parts that make up the whole represents the denominator. Okay, so now I'd like for you to stop the video again, and I'd like you to focus on writing a fraction that represents the shaded area and the non-shaded area for each shape. So how'd you do? For the first picture, there are a total of 8 little blocks, and 4 of them are shaded. So you could have written down 4/8, but 4/8 can be reduced, so you could have also written 1/2. Both answers would be correct. Now the non-shaded area, again, there are 4 non-shaded squares. So 4/8 would be non-shaded. Again, you could have written 1/2 because 4/8 and 1/2 are equivalent. Now in the second picture, there are a total of 10 pieces, pie-shaped pieces. Of those pieces, 4 of them are shaded. So you could say 4/10. Or since 4/10 can be reduced, I could have said 2/5. Both of them represent the same amount that's been shaded. Now the non-shaded part, there are a total of 6 non-shaded pieces. So 6 out of the 10 are non-shaded. Again, the 6/10 could have been represented as 3/5. How to write an equivalent fraction with the denominator, with a given denominator. So if I have something like 5/7 and I want to rewrite it as the equivalent fraction of some numerator over 35, the first thing I have to do is determine what was multiplied or divided to the original denominator to get the ending denominator. So 7 times what will give me 35? Just as multiplication can check division, division can check multiplication. So I could say, well, 35 divided by 7 gives me 5. So 5 times 7 would give me 35. So if I multiply the denominator by 5, I'm going to have to multiply the numerator also by 5 in order to create an equivalent fraction. And 5 times 5 would give me 25. So 5/7 or 25/35, they're equivalent. I'd like for you to stop the video again and determine or write an equivalent fraction for each with the indicated denominator, and then check your work with the answers below. So how'd you do? What times 10 will give you 80? Well, that's going to be 8. 8 times 9 is going to be 72. What times 40? Well, let's see. What does 42 need to be divided by in order to get 7? 42 divided by 6 gives me 7. So therefore, I'm going to have to take the 18 divided by 6 to get 3. And since I have a negative 18/42, to have an equivalent fraction, it's also going to have to be negative. But now it's going to be -3/7. Now my next one, -4/7, I'm looking for what do I multiply to 7 to get 49? That's going to be another 7. So I have to multiply my numerator, the top number, by 7. 4 times 7 is 28. So 28 negative, I have to, if the original one was negative, the equivalent one has to be negative. Now I have to think about what do I divide 14 by to get 7? Well, 14 divided by 2 is going to give me 7. So I'm going to have to take my numerator and divide it by 2 also. And 22 divided by 2 is going to give me 11. So 22/14 is equivalent to 11 over 7. Factors. The items being multiplied to obtain a product, the answer to a multiplication problem, are called factors. For instance, 3 times 4 equals 12. 3 and 4 are the factors, and 12 is the product. So when we are trying to determine what number to multiply to get the other number to get a certain value, we are really trying to determine what factor was used to get that value. A number divided by one of its factors will result in an answer that has no remainder. So 12 divided by 3 equals 4, no remainder. In math, this can also be stated as 12 is divisible by 3, because when 12 is divided by 3, there is no remainder. To determine a common factor is also determining a divisibility number. 3 and 4 are both factors of 12. Or one could say 12 is divisible both by 3 and 4. Reducing fractions. To reduce a fraction is to put it into an equivalent form where the numerator and denominator have no common factors. There's 3 different methods I'd like to discuss. The first one is to determine the greatest common factor, or the largest divisibility number they both have in common. And then once we find that number, divide the numerator and the denominator by that number. So let's show an example. 18 over 27. The biggest number that can go into 18 and into 27 is 9. 9 is the greatest common factor. So I take the top number, the numerator, and divide it by 9. And I take the denominator, the bottom number, and divide it by 9. 18 divided by 9 is 2. 27 divided by 9 is 3. So I've created an equivalent fraction. 18/27 is the same as 2/3. The second method is to determine a common factor, any common factor, not just the biggest, but any number that can go into both the numerator and denominator, and divide each of them by that value. But then you have to repeat the process again and again and again until the numerator and denominator have no more common factors. So an example of this would be 135 divided by 75. Since both the numerator and denominator end in a 5, 5 is a common factor. After dividing them both by 5, the result is 27 over 15. Both of these numbers share 3 as a common factor. So the numerator and denominator are both divided by 3, ending with a fraction of 9 over 5. Since 9 and 5 do not share a common factor, the fraction is reduced to its simplest form. So it's kind of like, how low can you go? You pick a number that goes into both of them, and you just keep looking for a common factor until there are no more common factors. And you've got your fraction into its reduced form. Method 3, which is the method your pre-algebra textbook shows, is to determine the prime factors of the numerator and the denominator. Once the numerator and denominator have been rewritten as prime factors, every like factor they share cancels to the value of 1. Any number divided by itself is 1. Factors left are then multiplied. All factors in the numerator to obtain the simplified numerator, and all factors in the denominator to obtain the simplified denominator. So let's give an example. 24 over 36. First thing I have to do is I have to find the prime factors of 34 and 36. Prime factors, prime means that it can't, there's only two factors, one in itself. So since the only two numbers you can multiply to get 2 are 2 and 1, 2 is a prime factor. And 2 times 2 times 2 times 3 equals 24. The prime factors of 36 are 2 times 2 times 3 times 3. Now that I have those in their prime forms, we call that factorization. When we put a number into the multiplication of its primes, the process is called prime factorization. Now that I've got it into their primes, I cancel what they have in common. The 2 over 2 goes away. For every pair, it goes away. On the top, I have 3 2's, and on the bottom, I only have 2. So that third 2 stays. Now, concerning 3's, I have 2 3's on the bottom, but only 1 on top. So only one pair go away. So my end result is 2/3. Now, when we're looking for the prime factors, one of the techniques is to use a factor tree. For 24, you think of two numbers that multiply to get 24. Any two numbers will work. And once you find one that's prime, a good practice is to circle it. So 2 times 12 is equivalent to 24, so that's two factors. Now 2 is prime, so it gets circled, but the 12, it can factor further. Two numbers that multiply to get 12 is 2 times 6. Of those two factors, the 2 is prime, but the 6 isn't. And then two factors that multiply to get 6 is 2 and 3. So now, if I bring all the prime factors down, I have 2 times 2 times 3 times 2, which if I multiplied all that back out, I'd get 24. Same thing with the 36. Two numbers that multiply to get 36 are 9 times 4. Both of those can factor further. 9 can multiply, two numbers that multiply to get 9 are 3 times 3, and two numbers that multiply to get 4 are 2 times 2. So then my prime factorization becomes 3 times 3 times 2 times 2. Notice that on the left they use x's for their multiplication, and on the right they show dots. As you progress in mathematics, you will no longer show x's because those become representations of variables. So you'll see the dots as you proceed in this class. I'd like for you to stop the video now and reduce the following fractions by any method of your choice that's given in this presentation. So how did you do? 48 divided by 36, the greatest common factor is 12. So that's the method I chose. 48 divided by 12 is 4. 36 divided by 12 is 3. So 48 over 36 is equivalent to 4/3. 27 over 81, the greatest common factor for that one, I didn't really use that one. I used the second method. I said, well, 9 can go in both the top and the bottom. So I divided both the numerator and denominator by 9, which ended up giving me 3/9. But 3/9 both share a common factor of 3. So I divided both of those by 3 and got 1/3. So the greatest common factor would have been 27. If I didn't spot it, I can just pick any factor. It doesn't have to be the greatest common factor. Now 240 over 600, both of them end in 0. Therefore, those two numbers are automatically divisible by 10. So I divided them both by 10 and got 24 over 60. Both 24 and 60 are both divisible by 12. 12 is a common factor. So therefore, I divided each of those numbers by 12 to get 2/5. 18 over 42, they have a common factor of 6. So I divided both of those by 6 and got 3/7. My very last representation was the prime factorization. I broke down every numerator into its prime factors and every denominator into their prime factors, and then I would have to cancel any pair that are right on top of each other that cancel each other out. For every 2 on top and on bottom, that goes away. You can see how this method also would give me the same results as if I would have divided the numerator and denominator by a common factor. We have reached the end of our video, and now I'd like for you to complete these 3 questions for your discussion board problem.